Hello everyone, welcome back to the power quality lecture series. Here we are going to discuss about over voltage. So over voltage is a kind of a long voltage variation. Here over voltage is an increase of RMS voltage to 1.1 to 1.2 per unit for more than 1 minute. That is 110% to 120% of its nominal value. The voltage is 10 to 20% is increased, and that is exists for a duration greater than 1 minute. It is comes under over voltage, and normal duration of under voltage is uh, over voltage is greater than the duration of voltage swell. So here you can see the pictorial representation of over voltage. Here actual voltage level, nominal AC voltage is 120 volt RMS, or you can see in a blue line, but there is a increase in the voltage from 110% to 120% for a duration that is greater than 1 minute. Here it shown two or more than 2 cycles. You can see this in the red color waveform. Here it is the voltage is increased above the nominal voltage value, which is shown in the blue line. So this is what is known as over voltages. So let us discuss what are the causes of over voltage. There are many reasons for occurring over voltage in a power system. First one I have listed here is that over voltages are generated by an insulation fault, is one of the reason. Then ferro resonance is another reason of over voltage, and faults with the alternator regulator, tap changing transformer, or overcompensation. These are some other reasons. Then lightning over voltages. If there is a lightning occurs, there is a chance of increase in the voltage. Then switching over voltages are produced by a rapid modification in the network structure, such as opening of protective devices or the switching of a capacitive circuits. So there are a possibility of reducing the load on the feeder also. When you are switched off some of the loads, or switching on of the capacitor bank, these also causes increase in the voltage for a particular duration. That is also comes under the causes of over voltages. And the effects of over voltages are, over voltages may cause over stress on insulation. There will be insulation breakdown occurs, problems of voltage instability, and demand for reactive power also increased. So these are the effect of over voltages. And as we all know that there are over voltage protection methods, different kind of protection method, and the fundamental principles of over voltage protections of load equipments are listed here. That is, limit the voltage across the sensitive insulation, divert the surge current away from the load. So you can use a surge diverter, block the surge current from the entering to the load, then bond ground together at the equipments, then reduce or prevent surge current from flowing between the grounds. So these are the some of the over voltage protection methodology in a power system. Let us move on to the next kind of power quality issue, that is sustained interruption. This also comes under a kind of long voltage variation. Here it is not a long, it comes under long voltage disturbance, long duration disturbance, but here the output voltage or current, there will not be any voltage or current for a particular duration. It is typically greater than 2 minutes or 3 minutes. So in case of IEC standard, a sustained interruption means it will be more than 3 minutes, and in case of IEEE standard it is greater than 2 minutes. So among all kind of interruptions, sustained interruptions is more severe. That means there will not be any output, means that that is a more severe kind of power quality phenomena, power quality issues. So in such interruption, voltage drops to 0 and it does not return automatically. In case of a sustained interruption, the voltage value drops to 0 and it does not return to the automatically to the normal position. So according to the IEC definition, the duration of sustained interruption is more than 3 minutes, but based on the IEEE definition, the duration is defined as it is more than 2 minutes. So frequency of occurrence and duration of long interruptions are two main aspects of assessing the ability of power system to deliver reliable service to the customers. That is, frequency of occurrence means if there is a frequent power failure, interruption means that there will not be any reliable power supply. So reliability can be assessed basically in terms of the frequency of occurrence of this kind of interruption and its duration. Here a diagram waveform is shown here. You can see that this is the voltage level, actual 100% voltage level, but for a duration greater than 2 minutes there will not be any voltage, and after that it will be reinstalled in state, but it is mostly manually the fault is cleared and this will comes, but the duration depending upon this duration, the reliability of the power supply can be ascertained. So that is what is the sustained interruption, and let us check what are the causes of sustained interruptions. So sustained interruptions are usually caused by permanent faults due to storms. So if there is a fault occurs in the your power system due to storm, there will be an interruption. There will not be any power supply. So trees striking lines or poles, these kind of things we in our power system, these kind of things are happening regularly. And utility or customer equipment failure in the power system, equipment failures, then miscoordination of protection devices. So consequently, such disturbance would result into a complete shutdown of the customer facility also. So these are the main causes of the sustained interruptions. So we will discuss the voltage imbalance, the next kind of power quality issue, in the next video.